This question on board involves a technical question that comprises both potential difference, current, internal resistance, external resistance, and the E.M.F, which is electromotive force. The question says a voltmeter is connected across a variable resistance R, which is in series with an ammeter and the coil. The cell E.M.F is E, and the internal resistance R. For a certain value of R, which is from variable resistance R, the ammeter reads 1 ampere and voltmeter reads 3 volts. When R, which is from variable resistance, is adjusted to another value, the ammeter reads 1.5 ampere. The ammeter reads 1.5 ampere and the voltmeter reads 2.5 volts. Neglecting the resistance of the meters, calculate the value of E and R. Calculate the value of the cell E.M.F E and also calculate the value of the internal resistance of the cell. So from this question, two steps are involved. One step is that this is a variable resistor. The variable resistance is adjustable. The variable resistance is adjustable. They did not tell us the value of the variable resistance, but we can get it from the values given to us. They say that the first step here is that when this variable resistance is adjusted a certain value, which we don't know, our ammeter in the circuit reads 1 ampere and our voltmeter across the variable resistance reads 3 volts. Okay. Then second step is from the previous step, then we now adjust our variable resistance again to a certain value again. Then our meter, which is ammeter on the circuit, now reads 1.5 ampere and the potential difference across the variable resistance now reads 2.5 volts when the variable resistance is adjusted another value again. This is variable resistance, this is variable resistance, this is our ammeter reads 1 ampere, this is voltmeter reads 3 volts, and this is our E.M.F, which is from the cell. And also the internal resistance is in the cell. It is in the cell, okay? So we're going to find the internal resistance of this cell and E.M.F of the cell, okay? Now let's solve. From the first diagram, we know that our E, which is electromotive force, is equals to current in bracket the variable resistance plus the internal resistance of the cell, which we need. Then this variable resistance can be gotten from the value of ammeter and the voltmeter, which we know that the external resistance, the variable resistance is equals to potential difference all over current, which is equals to our V here is 3 all over our current, which is 1. Then our value is 3 ohms. Let us calculate for the T is immediate so that when we come here, we will use the value. From this one again, the R from here will be equals to V over current again, voltage all over current, which is equals to our V is 2.5 all over current 1.5. We will get 1.67 ohms approximately. Okay, so the value of variable resistance here that is adjusted, we we got it through the help of values we've gotten from our meters, okay? Then our E here is equal to the current, which is 1 for the first step, in bracket R, which is 3 for the first step, plus R, okay? Which when we open it, we'll now have this times 1 times 3 is 3, plus 1 times R is R. Then this equation now will be our equation 1 from here. Now let us get the equation of this second diagram, which is also the same thing here, okay? So the current for this second equation here is 1.5 in bracket R. Our R here, we have calculated it and got 1.67 plus the small r. Then when we opening our bracket here, it will now be 1.5 times 1.67. We now have E equals to 2.51 plus 1.5 times R. We now have 1.5 R. This now would be our equation 2. But remember that from this diagram, that EMF here is the same EMF here. Therefore, E here is equals to E in this place, okay? Now, because of that, we can now have the right to say that the E that is in equation 1 here is equals to our E that is equation 2. Therefore, we can now equate this and this one, which will now have 3 plus R is equals to 2.51 plus 1.5 R. Okay, since this is equals to this, okay. Now collecting like terms, okay. Collecting like terms. We now have 3 here. When this crosses to this side, we now be minus 2.5 equals to what is remaining here is 1.5 R. When this crosses to this side, it will now be minus R, okay? And when we subtract, we now have 0.5 here equals to 0.5 R here, okay? Now, finding the value of R, okay? We now have R, this R is equals to 0.5 all over 0.5, which is equals to 1 ohms, okay? I repeat this thing I did here, that this making the subject of formula, okay? Making R subject of finding the small r, finding this small r here, have R equals to 0.5 all over 0.5, okay? Which is equals to R equals to 1 ohm. That is the internal resistance they asked us in our question. That is the internal resistance they asked us in the question. So the internal resistance value now they asked in that question is 1 ohm. Now let us find the E they asked us also in the question, which is the electromotive force. We can now use any equation to find the value of our E. If we can use equation 1, this one, to find the value of our E. We can also use our equation 2, this one, to find the value of our E. Now let me use the equation 1, which is E equals to 3 plus the internal resistance here. We have gotten it to be 1 ohm, which is 1. Then when we add them, it will now be 4 volts. So the E they are asking us, the value of E they are asking us from the question is 4 volts. This is how to solve this kind of question, okay? Please make sure you subscribe and follow, okay? Many more are yet to come. Thank you so much for watching, and God bless. Please comment, share, and like the video. Thank you so much.